The skies are clear, the stars are out, and Jupiter is shining in the sky. It's a perfect start to another three-night celebration of the wonders of space.
I'm Brian Cox, he's Dara, Briain, and this is Stargazing Live.
Welcome to a, well, slightly cold, but generally brilliantly clear, crisp evening here in Macclesfield.
It's what you need for astronomy. You can see Jupiter shining crystal clear over there. Absolutely beautiful. We are back at the Lovell telescope at the Jodrell Bank Observatory in Cheshire, and this telescope is genuinely one of the icons, one of the great historic instruments of space exploration and astronomy. I mean, here it is, 90 metres high, it is 76 metres in diameter, it's 3/4 of an acre in area. This was the only telescope of its time that could detect Sputnik when it flew over in the 1950s. It was used in the Apollo missions. It's a true icon of the space age.
And is both a backdrop and our headquarters, so settle down, relax, and prepare to be amazed by all the remarkable stuff that there is to see above your heads. Here's a look at what's in store.
Over the next 3 nights, we're going to be exploring the universe, looking at everything from the most distant stars and galaxies to our closest neighbour, the Moon.
We'll be tackling some of the biggest questions in space, like how do we find new planets outside our solar system? What exactly is a black hole? And what would we say if we actually made contact with aliens?
Now, there'll also be some very special guests, starting tonight with the commander of Apollo 17 and the last man ever to walk on the Moon, Captain Eugene Cernan.
Closer to home, we want you to join in as well. We need your help to try and find our very own stargazing planet.
And we'll be asking you to help us reveal the hidden wonders in the skies above Britain by turning off all the lights in this town live on air.
Plus, we'll be showing you what kit you need to get started in stargazing and telling you exactly what's out there to see in the night sky over the next 3 nights. Talking to Captain Eugene Cernan. The Apollo missions are the greatest achievement in human history. Just are. We haven't even had a debate about this, apparently, over the course of the day. This is not a thing we'd like you to email in on, apparently.
No, you'll get no change from me. They are. And we're talking to the last man on the Moon. I can't wait.
We'll be talking to him live from Houston in just a few minutes. We want to hear your questions for Captain Cernan and anything else in tonight's show. Email them to us at stargazing@bbc.co.uk, or you can tweet us via the hashtag BBC Stargazing. Jodrell Bank remains one of the most active astronomical research centres in the world, leading British research into quasars, gravitational lensing and pulsars.
Yeah, as I said at the start, this is a working observatory, and Dr. Tim O'Brien has joined us again. Viewers from last year will remember Tim. He's now Associate Director at Jodrell Bank. And this telescope is doing astronomy now, isn't it? What's it doing, Tim?
It is, yeah. It's actually looking at an object somewhere over there that's it's about 4,500 light years away, and it rejoices in the name B0818-13.
What is it?
It's a pulsar. It's the remnant of an exploded star that exploded some time ago. The centre bit of the star collapsed in on itself to make a dead star about the size of a city.
Yeah.
And as it spins, it produces radio waves that been travelling for almost 5,000 years and gathered by that telescope.
And that's just over there, star the size of a city. How fast is it spinning?
It's actually spinning about once a second, this particular one.
Right. Now, of course, you don't need a 76-metre telescope to appreciate the night sky. There is plenty to see with just the naked eye, as Mark can show us now.
Well, I'm out here with the members from the South Cheshire and Macclesfield Astronomy Society. How are you doing, guys? They sound like they're having far too much fun. We've got a great range of people, from absolute beginners all the way through to quite experienced observers, and a brilliant range of different types of equipment, from people who've actually got no equipment at all through binoculars and telescopes with complex computerized drive systems. But looking above me now, the skies are still clear. We had some fantastic views of Venus as it was setting in the west. We've got Jupiter high up in the southwest at the moment, and just behind my head, as you can see, we've got the great constellation of Orion with the red star Betelgeuse high in the top left corner. So hopefully the skies will stay clear. Check back later and we'll let you know how we're getting on.
And whilst we're here in Jodrell, the final member of our team, Liz Bonnen, has travelled all the way to South Africa for us, where the weather, well, during the day hasn't been as clear as this.
I love that. I love that. I love that it's worse weather in South Africa than it is in
Dara,
Macclesfield.
we were surrounded by rip-roaring storms earlier on, but thankfully they've appeased. So welcome to the South African Astronomical Observatory in the middle of the Karoo Desert. We are here because of that. The Southern African Large Telescope, or SALT. It's about to survey the skies in a little bit, which is why we are operating on specialist starlight cameras so as not to interfere with their work. But of course, you don't need a massive telescope like that to observe these beautiful night skies down here. We got some shots from this amateur, smaller telescope of the moon for you. Get a load of these. It doesn't get much better than that, does it?
Incredible images there of the moon. One of the things that we will be featuring on, we want to talk about the moon in the first show.
Yeah, we do. Now, the moon is the only place that we have ever set foot on apart from Earth. And although it's the most familiar sight in our night sky, it remains one of the most fascinating. Let's take a closer look. The moon has been our closest celestial companion for almost the whole of our planet's history. But we've always speculated about where it came from and what it's made of. The story of the moon starts at a time when the Earth was just a huge lump of rock and iron, sitting in the maelstrom that formed our solar system some 4.5 billion years ago. The environment in which the early Earth existed was chaotic. In all that confusion, it was hit by a smaller, rocky world. The collision almost broke both planets apart, but instead, the two bodies began to merge. Some debris from the impact was flung into orbit around the Earth. Gravity caused this mostly rocky material to clump together, forming our moon. Back then, it was much closer to our world and would have looked spectacular, cooling on the horizon of the hot surface of Earth. Over the next few billion years, the Earth and the moon exerted their gravitational forces on each other. The rotation of the Earth slowed. The moon's orbital speed decreased, and it moved away from us. It now takes just over 27 days for it to orbit the Earth, and today it is 225,000 miles away. It's still drifting away at a rate of 3.78 centimetres per year. When it's full, the moon is the brightest thing in the night sky. But through the month, its position in relation to the sun changes, and that means its appearance changes as we witness the shadow of lunar nighttime passing over its cratered surface. When it's in complete shadow, it's called a new moon. These different appearances are called the phases of the moon. Whenever we look up at it, we always see the same side staring back at us. Not surprisingly, astronomers have speculated about what the far side was like. We never saw it until the unmanned Russian probe Luna 3 went round the far side in 1959. These are the very images it sent back, rough and grainy, but still tantalising. Less than 10 years later, the Apollo 8 astronauts were the first humans to see the far side with the naked eye. They witnessed a much more densely cratered landscape than the more familiar near side.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep.
Less than a year later, Neil Armstrong and Buzz Aldrin took their first steps on the moon.
It's one small step for man, one giant leap for mankind.
There's no atmosphere to speak of there, and the gravity is just 1/6 that of the Earth. So the heavy spacesuits weighed less, making it easy for them to bounce around on the lunar surface. When the rock samples they brought back were studied, they were found to be made of silicate minerals containing familiar stuff like aluminium, iron and magnesium. The temperature on the lunar surface during the day is 133 degrees centigrade, but some craters near the moon's poles contain permanently shadowed regions that haven't seen sunlight for billions of years. It can get as cold as minus 185 degrees centigrade there, making them some of the coldest places we know of in the solar system. Most of our knowledge of the moon has been gained in the last 50 years, and we're still learning. Just 2 years ago, we discovered traces of water
frozen in the lunar soil, an intriguing discovery that adds to the mystery of our closest neighbour.
Now, those of you watching last year will remember that we had this high-tech touchscreen which caused loads of amusement. No one believed it was real and it didn't work. So we traded it in and we've got this one this year, which is controlled by this. So if I press that, then there we are.
No,
it's almost an image.
There
it is. This is an image. I want to talk a little bit about current research into the moon. I mean, this is the face of the moon that we're all familiar with. You see the seas and you see the cratered uplands. And there are big questions about why the moon, how the moon formed, why it looks the way it does. We know that these maria or seas are most likely volcanic, so they're new surface. So they're younger than the cratered surface that we see here. And when I say uplands, by the way, I really mean uplands. Some of those plateaus are higher than Everest. And we think that the moon is a lot smaller than the Earth. It's quite a remarkable feature.
It's the contrast we get between that side and the side we don't see, which I find particularly intriguing. I mean,
yeah, well, this is the so-called dark side. It isn't dark, it gets the sun, but it's the side that's permanently away from us. And you see that's completely different. You don't see the seas, it's very heavily cratered. And there's a new theory that perhaps, well, the old theory, the accepted theory, is the moon formed in some kind of collision. But the new theory is that there was another collision with another moon. So at some point in the distant past, 4 billion years ago, the Earth had 2 moons, and there was a collision, and that's why you see this discrepancy.
So you're basically seeing the debris from another moon on one or the other side of the moon.
So that's a relatively new theory. But now if we go, I want to show you these things. Actually, there's a video that I want to show you before this, which is, so I said that it's current research that we're looking at.
We're still sending, even though we're not sending manned satellites, we're still sending probes up, like the lunar reconnaissance.
That's there now, and this is an image, and it's a very detailed image taken. This is only 600 meters across. So you're seeing structure on the moon, you know, things just a few meters, a few feet across.
A question we get asked a lot, when it comes through an email all the time when we do this, is could we see from Earth, through any kind of telescope, the debris left behind by the Apollo missions?
The answer is no. And if I just show you actually where the Apollo missions are, so these are the landing sites. That's Apollo 17. I can try a new gadget on here. I can try and draw an arrow. That is where Eugene Cernan landed. We're going to talk to him in a moment. But these are the Apollo landing sites. You can't see that from the Earth. You need a telescope the size of Manchester. But you can see it from Lunar Reconnaissance Orbiter. You can see the debris. So this is a picture of the Apollo 11 landing site.
What's particularly interesting is watch the evolution of how much more confident they were about staying on the moon, about travelling around on the moon. From Apollo 11 to Apollo 14, I think, is the next one.
Yeah, and I think this is remarkable because this line here, I'll just draw a line underneath it, that's the footprints. So that's from just a few months ago, this picture from Lunar Reconnaissance Orbiter in orbit around the moon, footprints of Apollo 14.
Because there's no moon buggy for Apollo 14. However, they had a moon buggy by Apollo 17.
This is the most remarkable picture of all. So there, if I put an arrow to it, that is the moon buggy, the lunar rover, and Challenger, Captain Cernan's spacecraft, or the bottom half of it, the bit that didn't lift off, is sat there.
Why did they drive it to there, park, and then walk back? There's no particular good reason for that.
I think we should ask him.
We can ask the man himself. The other question, of course, is because there's no atmosphere, those tracks are going to remain there. There's no atmosphere to erode it, no wind to blow it away, no rain to get rid of it.
This is one of the reasons the moon is so interesting scientifically, because it's a fossil, if you like. It's deep frozen. It's the formation of our solar system is written there and has been for billions of years.
Okay, we can't tell you how proud we are to that joining us right now live from a studio in Houston, Texas, is the man who left those tracks and drove and parked that moon buggy, the commander of Apollo 17, Captain Eugene Cernan. Captain, thank you very much for joining us.
It's a pleasure to be with you. I'm disappointed I'm not with you. That description of the moon and what you're seeing there is it's got to be unbelievable. And I'm very proud to be here with you today.
Well, thank you, Captain Cernan. I wanted to start by looking back to the beginning of the Apollo program. I mean, we're talking 1961. Kennedy made that speech. We'd choose to go to the moon. He set America on a path to the moon within 10 years. And I know that you joined NASA in 1963. I mean, what was when you heard that vision for American space exploration, did you immediately think, I want to be part of that, I will apply to the astronaut program?
You know, those were the days. That was the speech that Kennedy gave, JFK gave, was about 3 weeks after Alan Shepard flew, and unbeknown to us, that suborbital flight indeed was probably our first steps to the moon. I wasn't even in the space program. I was just a young naval aviator and kept thinking, by the time I get good enough, there won't be anything left to do. It'll all be done. Along with the thinking that the president himself was asking us to do what most thought couldn't be done, to do what most thought was probably impossible. Go to the moon? I mean, think about that. We were just not too many years after Sputnik. And Yuri Gagarin orbited the Earth in, I think, a month earlier. And just put yourself back in that environment. It was an incredible challenge to mankind at that point in time, but particularly to the American people, to even think about doing it.
Captain Cernan, if I could ask one question about the trip you made before Apollo 17, because you were on Apollo 10, because the whole program advanced in by a series of successful further steps, and in Apollo 10, you had probably the most tantalizing of those, where you took the lander to within 8 miles of landing on the moon, and then came back again. I mean, what was that like?
Well, you know, we were the second flight to ever go to the moon. The first, I think, is one of the most historic flights, Apollo 8, where the first human beings ever left the confines of Earth to circle and orbit another planet. Well, I call the moon a planet sometimes, so I take a little license. But Apollo 10, we were going to go, and we're going to separate from the mothership. We were going to take the lunar module, the vehicle that was eventually going to take us down. And by the way, there was a lot of talk maybe months earlier that if we put ourselves in harm's way and we go all that distance, maybe we ought to just stretch it a little bit and go all the way down. I think the decision that was made, well, let's do everything but land. Let's, you know, I tell Neil Armstrong, we painted a white line in the sky so he wouldn't have to worry about getting lost, and all he had to do was cover that other 8 miles. But it was an incredible experience for me. I had no idea I'd ever had a chance to go back. But just being 250,000 miles from home, and here I was flying in and out of the shadows of another body out there in this universe of ours, you know, whether it's 225,000 miles or 200 light years at that point in time really doesn't make a lot of difference. And to be able just to look back at the Earth is a memory I think most of us can never forget.
And then, Captain Cernan, Apollo 17, not long later, just under 2 years later, you landed on the moon, spent 3 days on the moon. How was that? And what did you feel when you left the moon, the last man to stand on the moon so far?
Well, somewhat nostalgic, obviously, and those pictures you've been looking at are phenomenal. You know, it's for me, the first time I've really seen where we went from that point of view was when I saw those pictures, and I could see the shadow of the Challenger. I could see where we walked. I could see our lunar rover tracks. I knew exactly where I parked the lunar rover because I put it there specifically so the television camera could get our liftoff from the surface. Someone even told me, I guess one of your folks, do you know what direction you pointed the front wheels? And I said, well, yeah, I think so. I think I turned them in the left. He said, you're right, you did. I don't know how you can see that from here, but it's phenomenal. I guess someday someone will go back and survey those sites and get a little bit even better pictures than we've got now. But it was a mixed feelings. You know, we'd come all that way. We wanted to stay longer. We knew we couldn't. We knew we were part of something significantly bigger than us, a great technological adventure. But here we are, you know, a half a century later, and I still wonder today, what does it mean?
Well, Captain Cernan, we are going to return. We're going to return to some of these issues later in the show. We are going to talk to you later about the future of space exploration. Thank you very much for joining us, and we'll talk to you a little bit later in the show. For now, however, we go to Mark in the field with the good people of the South Cheshire and Macclesfield Amateur Astronomy Group to tell us what's visible right now.
Well, the skies miraculously are still clear for us. We've got the constellations shining brightly over our heads. We've got Gemini rising in the east now, which we can see with the two bright stars, Castor and Pollux, representing the sort of the side of the constellation of Gemini. The guys have been picking up some really crazy sights through the telescopes. We've seen star clusters in the constellation of Auriga, and we've even seen M31, which is the Andromeda Galaxy, the most distant object that you can see with your naked eye. So we're just keeping our fingers crossed that the skies are going to stay clear for us for the rest of the evening.
Now, last year you sent thousands and thousands of photographs in, and we want you to do the same this year, but we want to show you a few of the ones you've already sent in. If you want to send them in, by the way, go to the website, bbc.co.uk/stargazing, and you'll see all the details there. But let me show you a couple of the ones we've already received, because they are genuinely spectacular with my ridiculous control system.
How's that working out for you?
There it is.
Oh, big camera.
This is remarkable. This is M42 and M43. It looks like a genuine professional photograph taken with a big telescope. It's taken by Bill Swalwell.
In Wigan. This is what's happening in the skies above Wigan right now.
These are star-forming regions in Orion. Now, you can see this as a very misty patch with the naked eye on a night like this. But this is what you get when you...
Clouds of dust and gas that will eventually coalesce into stars.
Yeah, and you can see these are star-forming regions. There are young stars in there. And just one more that I wanted to show you, because it's beautiful. This is a picture from Mike Hyde in Swindon. This is of the crater, the very famous crater on the moon, Clavius and Tycho.
Okay, we'll be getting more as the show goes on, of course, and go on to the website if you want to join into the general discussion about it.
Send us some more of those. Now, I want you to take a look at this. This is what the full moon looks like in this country. This is the picture that you see on the left. And on the right, you see an image taken last night, I think it was, by Liz and the team in South Africa. And what's the difference?
Well, obviously, they're flipped around. And to explain why that would make a difference, where she is, here to explain it is Liz.
Who is it? Thank you very much. I'm inside Salt. More on that fantastic mirror later on. But first, the moon thing. Okay, so imagine if my face is the moon. No jokes, Dara, please. And I'm orbiting the Earth near the equator. If you stand on the northern hemisphere, you're going to see me the right way up. If, however, you are on the southern hemisphere, essentially my chin becomes the top, my forehead the bottom. I'm upside down. It's pretty simple, really. Now, there are parts of our wonderful universe that you can only observe from the southern hemisphere. And last night, I got a great look at the stars out here with Salt astronomer Petri Väisänen, who's been studying these skies for over 10 years. Petri, we get such a spectacular view of the Milky Way down here because, of course, we're pointing into it in the southern hemisphere, so we get to see many more of its stars. Yes. But what else is really special down here that we just can't see from the northern hemisphere?
One of the most famous constellations is the Southern Cross, of course, which you would never see from the northern Europe. 4 bright stars within the plane of the Milky Way over there. And close by to it are 2 bright stars, Alpha and Beta Centauri. Alpha Centauri is the closest star to our solar system, in fact. Excellent.
Now, of course, in the northern hemisphere, we've got the pole star. It's quite easy to navigate. But how do you navigate with this from to the south with the Southern Cross?
To the South Pole, yes. There's no individual star at the position of the South Pole, but you can use the Southern Cross and the pointers. You do it by taking the long diagonal of the cross, follow a line through the sky, and take another one from the pointers perpendicular to them, line similar way, and where those 2 lines cross, that's exactly where the South Pole is.
There you go. A little bit of calculations, but really nothing too taxing.
But you can do it, yes.
Excellent. And what else can we see down here then?
Another interesting object is Omega Centauri. Very low in the horizon at this moment over here, but you can see that fuzzy object over there. It's a cluster of stars, many of them, just outside the Milky Way, maybe 10,000, 15,000 light years away.
Beautiful. We're looking at an image that our cameraman took with his specialist camera. They really are quite spectacular. How many stars in that cluster?
It's about 10 million stars or so, and it's the brightest and the biggest of these globular clusters.
Beautiful.
Associated to our Milky Way.
One of the things I was really looking forward to seeing with my own eyes when I came down here were the Magellanic Clouds. Can you point them out to me?
Magellanic Clouds, they're these cloudy patches of sky right over there. There's large Magellanic Cloud and small Magellanic Cloud.
Look at that.
They're galaxies, separate galaxies to our own, circling our own Milky Way. So it's actually the furthest away you can see with your naked eye from where we're standing right now.
And that beautiful image is of the Tarantula Nebula in the large Magellanic Cloud, taken by this very telescope in the Karoo Desert. We'll find out more about that and the clouds tomorrow, but come back to me tonight. We're going to find out how that mirror works.
Thank you very much, Liz. Now, obviously, there's a slight twist in all this that we keep telling you about the moon. Hey, look at the moon. Isn't the moon great? There's no moon out yet. There's no moon for a while.
I know, shocking planning, isn't it? The moon doesn't rise until about 2 o'clock in the morning, but of course we want people to get outside after the show's finished to really enjoy it.
what have you got pointed now at the moment?
Well, this telescope is looking at the Great Orion Nebula. So if you have a peer down the eyepiece, you should see that, which is an object where stars are forming.
Nice.
Stars such as our sun will have formed
Very
in this
good.
big, huge cloud of
Good
gas
cloud
and dust.
of gas there, absolutely. Yeah, you can really see that.
You can see the glowing gas that's
nothing like
that's
the nebula for just a bit, because it looks sort of like a point or a very fuzzy point. The greater the telescope, the more magnification, the more detail you'll see.
The more you'll see. Anyway, let me introduce to Helen.
Hey,
Helen's a
Helen,
member of the Macclesfield Astronomy Society. Now, Helen, how long have you been interested in astronomy?
Well, I got a telescope for Christmas.
Nice, very good.
And I've always looked at the stars and things, but I wanted to see it with a bigger eye, so hence the telescope.
Oh, you're complete newbie,
complete.
And it's only been just a few months you've been interested, isn't it?
Yeah, well, a few weeks really, because it was only Christmas. But I've learnt so much tonight. I'm so excited. It's brilliant.
And have you seen some brilliant things with the telescope so far?
Jupiter. I've seen the lines around Jupiter. And the other day, I actually, with my own telescope, I saw the moon and the craters, which was amazing. So all of it is very, very exciting.
And you're enjoying it?
Love it.
Brilliant stuff. Well, one of the biggest questions we were asked last year was what kind of equipment you need if you want to get into astronomy. So we've put together a very special guide for you, and what better place to start than the place that Captain Cernan went to 40 years ago.
The moon is a constant presence. It's close to the Earth and it's visible nearly every day. While stars and planets come and go, our closest neighbour is with us throughout the year.
These characteristics mean the moon is a fantastic object to focus on if you want to learn more about looking at the night sky. And the great thing is that observing the moon is really easy to do. Even just using your naked eye, you'll be able to pick out markings on the moon's surface.
And if you're inspired to take a closer look, it won't break the bank. You can even try it from your own back garden.
A great way to begin observing the night sky is through a pair of binoculars. Now, you can use any binoculars, but these ones are a good pair for astronomy. They're known as 15 by 70, which means they magnify 15 times, and the lens is 70 millimetres across. And I've got them on this tripod to help hold them steady.
A decent pair of binoculars cost from £50 and will make features on the moon's surface begin to stand out. You can find craters along the line of shadow between light and dark, and see the Sea of Tranquility, where the first men to land on the moon touched down. But that's just the beginning. If you find yourself getting hooked, you might want to try using a telescope.
I remember the first time I looked through a telescope. I was 10 years old and I was blown away by what I saw. And no matter how many pictures of space you look at, there's nothing that quite beats seeing it with your own eyes.
A telescope will allow you to explore great flat lunar plains at the top of the moon and mountain ridges running between them. The image appears to ripple because we're looking through the Earth's atmosphere. In the lower half, you can see a rugged landscape marked by thousands of impacts over billions of years. Optical telescopes come in a range of sizes. A good amateur one costs around £150 to £300.
The key factor for any telescope is its diameter, or its aperture. Now, the wider the aperture, the more light a telescope will collect and the more you'll be able to see. And depending on the type of telescope, a good starting aperture is between 3 and 6 inches, which is around 8 to 15 centimetres. And how much a telescope will magnify an object is determined by the length of the telescope and by the eyepieces, which slot into the telescope just over here.
This is a crater known as Copernicus, which has been magnified around 50 times. And this is it, seen with around 100 times magnification. It's the same telescope, but with a more powerful eyepiece. There are two basic types of telescope, and which one you want depends partly on what you'd like to see.
Now, if you want to get the best view of bright objects like the planets or the moon, then a telescope with a lens inside it might be just right for you. It's called a refractor, and you look through it like a ship's telescope along the tube. But if you're particularly interested in looking for faint, distant objects like galaxies or nebulae, then you might want to consider a telescope that uses mirrors to reflect the light, and it's known as a reflecting telescope. And with this telescope, you look through the side of the tube at the top because you're looking at reflected light off the mirror.
Both types of telescope will give you a good view, but beginner reflecting telescopes tend to be bigger than beginner refractors, making faint, fuzzy objects easier to see.
If you want it really easy and you've got a bit more cash to spare, you might want to think about one of these. This is a computerised or go-to telescope with motors. They start at around £300, and if they're set up correctly, they'll take you to any object in the sky at the push of a few buttons. So, if I want to look at Jupiter, I can select Jupiter off a list on this handset, and once entered, the motors will swing the telescope round until Jupiter is in the field of view. Now, I've replaced the eyepiece for a webcam and attached the webcam to this laptop computer so you can see what's happening. And there it is.
Any good amateur telescope will allow you to explore the solar system with your own eyes. You can find the moons that orbit Jupiter, view the planet Saturn with its icy rings, and even make out the red glow of one of the smallest planets, Mars. And the best thing is that it's a real live view.
With a bit of research and some patience, there's nothing that beats looking up and realising that what you can see really is there, hanging in space millions of miles away. Now, one other thing to think about, of course, is telescope mounts. You need to make sure that whichever telescope mount you get is solid, because the telescope needs to be held really firmly to make sure you get a nice, steady image. Now, if you're not sure, go to your local telescope shop, and I'm sure they'll be able to help you out. Now, we've put together a special guide for equipment on our website, which is at bbc.co.uk/stargazing.
Thank you very much, Mark. On the website, you'll also be able to download this year's Star Guide, done in cooperation with the Open University, which is a whole section dedicated to the moon and obviously things about the constellations. There'll be links to the Open University's virtual microscope, where you can get up and close and personal with real moon rocks and meteorites. Plus, you'll be able to see a film explaining our more unusual moon myths, their historical basis, telling you, amongst other things, where the idea of the moon turning men into werewolves came from.
Stop it.
It's very important stuff, don't you like?
It's grist to the hippie mill.
Oh, stop with the thing. That man is just another Capricorn with a difficult time in his love life.
Don't.
Okay. All of it, bbc.co.uk/stargazing. Stargazing, excuse me. We're now in the Planet Centre, which is a new part of Jodra, where we'll be for the after show, where there'll be more discussion and more questions, and that'll take place immediately after this main show.
What star sign are you?
Oh, do you know, but it makes me flighty and excited.
The unusual thing about our moon is its size relative to the Earth. Now, it's one of the, it's not the biggest moon in the solar system. This is actually, we think, a picture of the largest moon in the solar system. It was taken about an hour ago, so it's Jupiter, and we are fairly sure that point of light there is Ganymede.
Now, Ganymede is much more massive than our moon.
It's bigger than the planet Mercury, but relative to Jupiter, it's tiny. Now, it is worth saying, actually, that if that is Ganymede, and I'm sure you'll complain if it isn't, then that could be a place that harbours life, because we believe it's so big, and because of the tidal influences of the planet on it, it may have a liquid ocean beneath its surface. So it's a fascinating place. I think looking at that live just tells you about the magic of astronomy. It's fantastic, isn't it? Anyway, because, as I said, our moon is so big in relation to the Earth, it has profound effects, not least on the way it controls the movement of our oceans.
Have you ever wondered what causes the tides? Well, of course, it's got something to do with the moon. But what exactly is it that causes the ocean to roll up the beach and roll back again twice a day?
The tides are caused mainly by the gravitational pull of the moon. So here is the Earth, and here is the moon. Now, the gravitational force on any point on the Earth just depends on the distance between that point and the moon. That's Newton's law of gravity. Imagine the ocean surrounding the Earth and take a point on the ocean. What you'd have to do to calculate the gravitational pull would be to work out what that distance is. Or let's say we go to that point. It's further away from the moon, so the gravitational pull of the moon will be less. And again, we just have to calculate that distance. Here, we'd have to calculate that distance. So you can see that the gravitational pull of the moon on the water changes depending on where you are. Both the direction changes and the strength of the pull. The upshot of all that is that the ocean gets deformed. The shape of the water gets pulled and squashed into a kind of rugby ball shape. So you get a bulge of water facing the moon, and because of the way that this difference in gravitational pull works, you get a bulge of water on the opposite side of the Earth to the moon. And these bulges here are the high tides. So today, moon is just over there actually, somewhere close to the sun. So we're in this position, almost directly beneath the moon, and that means that we're beneath this tidal bulge. And that is why on this beach at this moment there's a high tide.
But what about a low tide? Why does the water go back out again?
Well, the tide goes out because the Earth is rotating. See, at high tide, then I am standing here on the beach beneath the tidal bulge, and the moon is just positioned in the sky over there. But if I wait 6 hours, give or take a bit of movement of the moon, then the Earth will have rotated. So this beach will have moved. I'll be stood here. That is low tide. So it's kind of tempting to think that it's the water that's moving. You know, it's in the language, the sea is going out. Well, it's not the tide that's going out. The tidal bulge is in the same place. What's happening is that rather than the water going away from me, I am going away from it.
Water is fluid. It moves and flows, so it's easy for the moon to distort the shape of our oceans. But the moon's gravity doesn't only pull on the oceans, it pulls on our entire planet.
So now at high tide I'm standing next to that bulge of water, but I'm also stood on a bulge of rock. The solid Earth is being deformed, stretched and squashed by the gravitational pull of the moon.
So at the same time as the oceans, the whole Earth is being stretched into a rugby ball shape by the moon. But it's much harder for the moon to distort the shape of solid rock than the shape of liquid water. So the distortion is tiny. We don't even realise it's happening. But it's a different story for the moon, because just as the moon raises tides on the Earth raises tides on the moon. Ever since it was first formed over 4 billion years ago, the solid body of the moon has been stretched and squashed by the tidal forces of the Earth.
If I were able to stand on the lunar surface 4 billion years ago, looking up at the Earth, then I would see a giant rock tide raised by the Earth's gravity on the surface of the moon. It would have been about 7 meters high. That's about as high as that dune.
And as the moon rotated, that bulge of rock would sweep across the surface of the moon, just as the oceans sweep across the surface of our planet.
So the Earth raises that tidal bulge on the moon, but because of the moon's rotation, that bulge is always slightly ahead of where the Earth is. So that meant that the Earth's gravity acted like a brake. It pulled on the bulge to slow the rotation of the moon down. Now, over time, millions, billions of years, that meant that the moon's rotation rate slowed. And in turn, that meant that the moon drifted further and further away until you get to the situation we have today,
where the moon has slowed so much, the time it takes to complete one orbit is almost exactly the same as the time it takes to rotate once on its axis.
So the moon's rotation has become synchronised so that one face always stays pointing towards the Earth. And that's why we only see one face of the moon when we look up into the night sky.
Tides are caused by one of the fundamental forces in the universe, gravity, and they bend and stretch rock as well as oceans. Tides distort the shape of our entire planet, and they've slowed down the rotation of our moon. So tides are much more than just the gentle roll of water up and down the beaches of the world.
Now you can see the effects of tides all over the solar system. In 1979, the Voyager spacecraft made a remarkable discovery which I think shows you graphically the power of tides. So this is a picture of the Jovian system, the Galilean moons we saw one live earlier on. And this is the inner of the moons, the large moons of Jupiter called Io, and it's the most volcanic place in the solar system. And back in 1979, it wasn't thought that this was possible. It's too small to have any internal
So
heat.
it's not like a volcano like we would have on Earth. It's not the molten rock from its creation bursting through the surface. It's not
the heat.
steam, it's not heat.
It's not the heat from creation, but it is molten rock. And what's happening is Io is maintained in a very elliptical orbit around Jupiter by the other moons, actually. So it's quite a remarkable, it's called a resonant system. But basically Io is in a very elliptical orbit, so it passes close to the planet and far away, and close and far away. And that means it gets stretched and squashed and heated by the immense tidal forces of Jupiter. That melts the rock, and Io turns itself inside out with volcanism.
So it's its own stone that is dropping out on constantly, spilling out onto the surface.
Yeah, it's a remarkable place. And it's kept in that orbit by the other moons, the interaction of the other moons. So it's an incredibly complex and beautiful tidal system. But I think it just shows you the power of tides. It's not just oceans lapping up onto beaches.
Now, we've had a number of questions coming through as well. Sean Deegan in Tipperary asks why, and he's underlined why is the moon slowly moving away from Earth?
It's in physics language, it's called the conservation of angular momentum. The reason is because there's a fixed amount of spin, if you like, in the Earth-Moon system. And because, as we spoke about in the film, the Moon is slowing down because of this braking effect on the Earth. The spin has to go somewhere. It's what's called a conserved quantity. So the Moon moves further away, and that takes the spin that's lost.
And why does the moon, asked Greg from Watford, look like it's made of uniform dusty rock, while the Earth is made of black rock, red rock, diamond, mud, much more varied?
Well, the red rock is rust. So you need oxygen in the atmosphere. So the answer is the Earth has been transformed by not only weather, but also by life.
And that's one of the things, of course, we've no oxygen, there's no oxygen in the atmosphere, things can oxidise as well as erode, so it's unchanging.
That's it, and the oxygen in our atmosphere came from life, it isn't there naturally.
Now, Liz Bonnan has already shown us the amazing South African skies tonight, but that's not the only reason she travelled to the Karoo Desert for us. It's also home to one of the world's finest collection of telescopes.
I'm still inside the SALT telescope, and tonight light from millions of light years away will be filtering down onto this mirror downstairs. Astronomers are gearing up for a night of stargazing, but how did the SALT telescope actually end up out here in the middle of the desert in the first place, and what is it looking at up there? This is where modern astronomy began in South Africa. The first Royal Observatory was built here in Cape Town in 1820, and for the next 150 years, it's where stargazers from all over Africa came for the best view of the night sky. But eventually, starlight got drowned out by city lights, and the South African Astronomical Observatory had to go in search of somewhere a little more remote. And it doesn't get much more remote than this. Over 200 miles northeast of Cape Town, the Karoo Desert is one of the most inhospitable places in Africa. But at more than a mile above sea level and with clear, unpolluted skies, it's the perfect place for a new observatory. That's why astronomers from all over the world come to Sutherland, with hundreds more operating these telescopes remotely. It really is a global operation. Astronomers here and in Japan use this, the IRSF telescope. It uses infrared light to peer through the dust of the Milky Way and gain a new view of our galaxy. These are the Solaris telescopes run by astronomers in Poland, and they're on the hunt for planets outside of our solar system. KELT, the kilo-degree extremely little telescope run by scientists in America, surveys huge parts of the sky, but it's quite possibly the smallest professional telescope in the world. And this is the 1.9-meter telescope, a pioneer in helping us to understand the very center of our galaxy. And at one point, this was the largest telescope in the southern hemisphere. But now, they've got this. A telescope with the ability to look much deeper into our universe. One of the biggest telescopes on Earth, the Southern African Large Telescope, or SALT. David Buckley is the astronomer in charge of what's been nicknamed Africa's Giant Eye.
SALT is the largest single segmented mirror telescope in the Southern Hemisphere. So it consists of this array of 91 individual mirrors that are held in precise alignment to give perfect images. It allows us to look at objects that are 1 billion times fainter than what you could detect with the human eye. That means you can look at objects at the edge of the observable universe. The very first galaxies to have actually condensed out of the matter after the Big Bang.
So once the mirror has gathered all that light, how do you analyze it?
So in one instance we have effectively a fancy digital camera that takes a picture of a part of the sky. For example, this is an image of what's called a gamma ray burst, which is a very distant energetic object that suddenly exploded.
Okay.
Looking at that image on its own tells you very little, but when you disperse the light with a spectrograph, you get this sort of picture, which is a spectrum, and this tells me immediately that this is a very distant galaxy, and these features in the spectrum tell us what the intervening material is that's absorbing the light between this distant object and us, and how fast it is moving as well.
So you've basically got photometry that allows you to
Photometry
see
and
the
imaging,
object,
that's right.
with a great camera.
Yeah.
And then spectroscopy, which splits up the light so you can learn more about the properties of that object.
Indeed, yes.
So what exactly are you looking at with SALT right now?
It's basically looking at everything that astronomers are interested in, everything from the closest objects, what we call near-Earth objects, which are asteroids that are very close to the Earth's orbit, possibly threatening the Earth at some point in the future. We're even discovering planets around other stars. And then the nearest neighbouring galaxies to the Milky Way, so the Magellanic Clouds, which are only observable in the Southern Hemisphere, they're particularly interesting. There's just a whole zoo of different types of galaxies that interest astronomers in many different ways.
And that huge mirror is above us. This is a control room where all that light is processed by astronomers. David, you actually observe the night skies from many different institutions all over the planet, is that right?
That's right. We observe at least 10 proposals a night out of
nice.
many dozens.
So what are you going to be looking at tonight, and for whom?
Well, one of the proposals we're doing is looking at very young, distant galaxies that formed after the Big Bang, and so that's a program for our partners at the University of Nottingham.
Lovely stuff. And you can look at these objects in the skies through filters to look at their colours, is that right?
That's right.
Can we talk through some of the images that SALT takes? This one is beautiful, and I think I know what that is. Talk me through it.
This is called the Lagoon Nebula, Liz, and it's a big cloud of gas in our Milky Way, which is embedded with very hot young stars. And these stars emit huge amounts of ultraviolet light, which cause that gas to fluoresce and cause that beautiful coloration.
Absolutely gorgeous. And of course, the next image we have is a planetary nebula, which in a way is the other end of the spectrum when it comes to stars, isn't it?
Exactly. This is the end point of stellar evolution. Some stars go through a period in which they expel a huge amount of their material into this sort of shell.
Yeah.
But the whole star doesn't disintegrate. In the center of the nebula is the remnant object. Which
is that the dwarf star, is it?
Yeah, it's a compact object like a white dwarf or a subdwarf.
And then the last image we have, oh, stonking, it's a spiral galaxy. Which one is this in particular?
This is NGC 1365.
Snappy name there, David. It's very lovely with all these starbursts, as you can see.
Yes,
absolutely
it's a barred spiral,
gorgeous.
very similar to our Milky Way galaxy.
Excellent. And we're going to be talking about galaxy evolution right here at SALT tomorrow night. I will see you then.
Thank you very much, Liz. Now, I'm delighted to say that the commander of Apollo 17, Captain Eugene Cernan, is still with us live in the studio in Houston, Texas. Captain Cernan, if I could ask you very, very quickly, we referred to you earlier on as the last man to walk on the moon. It's nearly 40 years later. Are you surprised or disappointed that we're still referring to you as the last man to walk on the moon?
Well, I like to think of myself as maybe the last man of Apollo, last man of the 20th century. We're going to go back. Curiosity is the essence of human existence. You know, I'm listening to your show and I'm trying to visualize what you're seeing, and I'm, you know, the unknown. The universe is so full of things we want to know something about, and you know, going back to the moon is just the first next step. I think we'll go from there without question to Mars. We ask ourselves, who are we? Where are we? Where did we come from? How did the Earth get here? Is there life out in outer space? You know, and you can define life as we know it, or maybe there's some other definition of life. I don't know. But there's no question that mankind will continue to explore and move out into this universe. And of course, there's no end from my point of view. So this can go on ad infinitum, forever, however long forever is.
You know, Captain Cernan, there's a conference, I think just at the end of last year, which was called the 100-Year Starship Conference. I don't know if you'd heard of it, but the idea was that building a starship to go beyond the solar system to the stars would be a 100-year project in the way that we used to build cathedrals. So what can we do to make human society come together to want to make those grand leaps into the unknown in the way that building a cathedral was 1,000 years ago?
You know, if you look back at what space has done, one of the lesser discussed things, that it has brought human society as we know it here on Earth much closer together. I mean, we can share everything from athletic events to disasters that occur on this Earth almost instantaneous. We can share the sorrow, we can share the enjoyment, we can share the challenge already. And, you know, when we will go to Mars, and when we go, I think it will certainly be an international venture with, you know, a combination of our intellect, our intelligence, our all of the capabilities we have put together in one pot. And that's just the very next, quote, near step. It might be a generation away, but that's not that far.
Captain Cernan, we've had questions coming in from viewers throughout the show, and I'm just going to read you one from Ian in Northumberland. I think cuts to the nub of an issue here. When I go to start my car in the morning, Ian writes, there's always a moment where I think it's not going to start. Did Captain Cernan have any thoughts like that when he was on the moon?
Yeah, that's a good question. I grew up in Chicago where the winters get pretty cold, and you go out there to start that car in the morning, and you're not sure it's going to turn over. You know, you don't, if you were worried about that, you worry about it before you go, and if it really bothers you, you don't go. But once you get there, you've sort of what I consider bit the bullet. Enjoy it, enjoy those 3 days, make the best of it, get as much done as you can, and when the time comes to go back, and of course, we built redundancy into the spacecraft. Now, there's a point at which there's no redundancy, there's only one engine, and things have to work right. I never, ever went to the moon not to come home. Did I ever think about it? Yes, but what would I have done if, quote, when you turn the key, it didn't start? Quite frankly, I don't know, and I'm glad I don't have to answer that question.
Captain Cernan, we've run out of time, but can I just say it's been a genuine pleasure talking to you. I said earlier in the show, I think the Apollo missions were the greatest human achievement, and I think the Mars missions will be the next greatest achievement. But thank you very much for joining us.
Well, it's a pleasure. I really feel like I missed the best part of the show by not being there with you, because I was listening and fascinating by what you're talking about. I think the element of time and our misunderstanding or lack of understanding of time is so important to what we see out there. So, you know, open it up to these young kids, inspire them to dream in the impossible, and the impossible will happen.
Thank you very much, Captain Eugene Cernan, joining us from Houston, Texas. Let's take a look how it's holding up for Mark and friends outside here at Jodrell.
Well, I'm here with Andrew Greenwood, who's the chair of the Macclesfield Astronomy Society. Of course, Andrew, your society started here in the 90s at Jodrell Bank, didn't it? But what is it that you get out of astronomical societies?
It's just great to bring lots of people together under the stars and the planets, as we're doing now, and just experience the camaraderie. There's nothing like it. It's exciting, enjoyable. Just get out there and do it. It's fantastic.
And you can learn so much from each other as well, which
Wonderful.
is amazing,
Yeah.
isn't it?
Yes.
Well, we've seen some brilliant sights in the skies over Macclesfield tonight, and if you want to know what to look out for later on tonight, you can tune in to the Back to Earth show, which follows immediately after this show, and I've got a special guide for you on what you can look out for and where it is in the sky. But as always, it's reliant on the weather and whether we get clear skies. So to find out what the skies will be like where you are, here's Alex Deacon from the BBC Weather Centre.
Thanks very much, Mark. It's pretty clear out there countrywide at the moment. So I'm just going to spin things around a little bit and show you the picture from space back down across the UK this afternoon, because it does show largely clear skies. However, there are one or two troublesome aspects. This line of white, that is clouds spilling in across parts of Northern Ireland and Western Scotland. So here conditions are, well, far from perfect. But across the bulk of England and Wales and much of Central and Eastern Scotland, we've got clear skies tonight. Just a little bit of cloud here and there, a little bit of mist here and there. But overall it is clear. But take notes, that blue hue on the map is telling us it is also pretty cold outside. Temperatures widely right now down below freezing. So if you are heading out after the show, you might want a few layers on. Tomorrow night, well, it's nowhere near as cold, but unfortunately that's because there'll be much more cloud in the sky. There is the possibility that some eastern areas will have clear skies for a time tomorrow evening, but overall expected to be cloudy tomorrow, and that blue on the chart, well, that is rain tomorrow night. So it's not as cold tomorrow, but it will be much, much cloudier. Perfect conditions, though, almost tonight. It's back to Dara and Brian.
Well, thanks, Alex. Now, as we mentioned at the start of the show, this year we want to try something very special. Indeed, with your help, we want to try and find our own exoplanet. That's a planet around a distant star.
To do this, we've teamed up with Zooniverse, the online citizen science project, and their Planet Hunters experiment. Here to explain how it's going to work is actually Chris Lintott, the founder of the project and co-presenter of The Sky at Night. What is it you're trying to do?
Well, we can't see these planets directly. They're way too faint. So we have to look for the blink that happens when the planet gets in the way of its parent star. We have a space telescope up there called Kepler. Looks at 150,000 of these every 29 minutes, and it sends a measurement of their brightness down to Earth. There's Kepler on the screen now. We can look at that data, and we're looking for those tiny dips. So that's right, yeah, you see a planet going in front of its star. We don't see a picture that good, we see this dip. And if you see one of those, you think you've got a planet.
Now, the obvious question is, why doesn't Kepler, why don't they do it with computers?
Well,
why are we doing it?
Computers have a stab at this data. In fact, it was only released to us after the computers have got their hands on it. But we know humans can find things computers can't. We're good at pattern recognition.
Let's have a look at the kind of patterns we're talking about here. I mean, because
that's right.
You've got a counter of what we're talking about.
We have, which will
show about 48 hours to find a planet. That's already counting down. And there's dips like that.
That's right. A blue box should appear on it shortly. So each point is a measurement of the star. You see a dip like that, we've got a planet, and a computer missed this one. So this is one that a human found and a computer missed.
And just to be clear, what do our viewers have to do?
They have to go to planethunters.org. There's a little tutorial. 6-year-olds can do this and then get clicking. And if we get enough clicks, I'll be back on Wednesday and we'll have found a planet.
The more clicks you have, the more opportunities you have of getting. You could find your own planet. We will make you a god. We will have statues for you.
We're going to call it the Dara planet.
We'll send you there, Dara.
Thank you very much.
Well, obviously, to have the best chance of us finding anything, we need as many of you as possible to take part. It's free. There's a tutorial on the web. You don't have to register if you don't want to, so you can spend as little time or as much time as you want there. Why would you spend a little bit of time trying to find your own planet?
To take part, go to bbc.co.uk/stargazing and click on the box that says Find an Exoplanet. Chris will be answering questions on our live blog on the website for the next 20 minutes. We'll be back as a Wednesday night, and we'll have a longer discussion about it, and hopefully we will say about what we've found. Tomorrow night, we're back, of course, with John Coleshaw. Wednesday night, John Bishop. That's what we'll be doing.
John's getting better and better at doing an impression of me. He just stares wistfully at the sky more professionally than I do.
Now, we want you to get out and look at the moon and send us your pictures. Don't forget that we'll be back in this very room very, very soon. Get onto the website and start hunting for planets, of course.
Yeah, I think that's one of the most remarkable things. It's real science, isn't it, essentially? I mean, we can really add to the sum total of human knowledge. So I think you should do that. Add to the sum total of human knowledge.
We'll see you back in about 2 minutes with a more relaxed chat with some of your questions. We'll see you shortly, or we'll see you tomorrow.
See ya.